This has been a wonderful summer. I've been pinching myself the whole time. Wonderful group of interns and mentors. I really appreciate that. So my project was this health monitor for many of the systems that NCO has running, by which they serve data to the public and to other stakeholders as well. So the main need for this health monitor is that data has to get out to customers. NCO provides data to many people who have impacts on the life and property of the nation all over the place. For example, of course, the National Weather Service itself, weather.gov, and as Riley's presentation showed, most people will go there to get their weather information, and additionally, the private sector will use this information to make predictions about their business, when they need to be doing various things, broadcasting that you see on the television, that you'll hear on the radio, that you'll see on your phone or here. Most of that data comes from the National Weather Service. People may run their own privatized algorithms to forecast differently than the National Weather Service would, but the original data comes from NWS. And finally, here's an example. The FAA is another government organization that uses NWS data to show whether or not they should be flying at certain times and when it's safe to run their flights or when they need to be canceled. So it's an important cause. And NCO has to be informed about whether or not the data is making it to the customers. And this is an example from several years ago, May 2014. There was a horrible thunderstorm in this very area, actually. There was hail the size of golf balls. Wind was blowing at more than 60 miles an hour. It was very dangerous to everyone, and so the National Weather Service naturally sent out a warning to the public. And they did that, and they were done with it, but it didn't make it to the public, despite them having sent it, and the reason was a firewall had just been upgraded and the data couldn't get through the firewall. So this was a situation where the National Weather Service on their end, everything looked fine, but to the customers, they couldn't see it. So it had high customer impact and impact on the American public. So this is why we need to monitor the systems. And this is, right now, this is called Big Brother. This is what NCO currently has for the most part. And Big Brother is able to provide a wide range of information about system health on NCO's side. So it can determine what scripts are running, what cron jobs are scheduled, the health and the status of the hardware, and it helps employees across the National Weather Service understand the system health in real time. It's an excellent piece of software. I recommend checking out the Wikipedia page. It's very comprehensive, but it does have some drawbacks. Big Brother does not know what the data should look like. It will flag green for partial data, even if some of it is missing. It does not show customer impact. It does not show what the customer is seeing. And the first question from the National Weather Service headquarters and from management is always, what is the customer impact? And historically, NCO has had a very tough time answering that question. So that's what this health checklist is for. Please click that forward. Thank you. So yes, NCO needs to see the customer impact. And so this is what they use right now to determine customer impact. This is a Wikipedia page, several pages long. Look at all of that. And just for an example, that's MRMS. I made one monitor for this particular application. These are all the steps they have to do. These are manual steps. They are clicking, they are looking with their eyes at data, they are searching through very complicated, difficult to read data sets. And it's extremely time consuming to do all of this. And right now we've converted this to something that can be done at a glance with no manual interaction. And the reason that this has been so difficult for NCO is that it takes experts' times away from solving the problem and makes them spend time looking for the problem. And that's not a good use of their time. So that's why this checklist is very necessary. And the checklist does 3 things for each application. It shows the uptime of the website. So if you get any HTTP code that is not 200, which is okay, it will show that. It will show that the website is down and that customers cannot access that. It also shows product timeliness. This is weather data. So no matter how accurate it is, if it's not on time, it can't be useful to the public and to other stakeholders. And finally, it shows download speed to make sure that the websites are serving up the data at a reasonable speed and to help detect any problems that might be happening with that. So those are the 3 things the health checklist does, and it does it at 2 locations. There's a data center here in College Park that some of you may have seen, and there's a data center over in Boulder. and it checks both those locations, and additionally, when a user goes to a website, it will automatically direct to one of those two locations. That depends on health of the systems. If one of them fails, the default will fail over to the other side. So that's called the primary location, and that can switch back and forth. And so we're monitoring that as well to see what customers will most likely be seeing. So right now we have two applications on the health monitor. NOMADS is that actually stands for NOAA Operational Model Archive and Distribution System. Most of you are very, very familiar with that. And MRMS, Multi-Rater, Multi-Sensor. But we're leaving documentation behind so that other people can maintain it. So this is a little overview of how the health checklist works. So here's an example website. This is lightning data, and these are the files, and we're checking them for timeliness. So the scripts will go, they will run, they will pull data from that website, and they will put it into a CSV, as you've seen here, and they're constantly collecting data. So once that CSV has been generated, it will make 3 websites, but other scripts will run to produce these websites. 3 different views for each application. The first one is the index page. This was an old screenshot. Now we have 2 buttons, one with nomads, and there's a list of buttons, one for each application. And the button color actually says how the health of the system is doing. This is a little bit blurry, I'm sorry. But right now it's yellow, which means that it's not completely healthy, but it's not to the point of emergency concern. And because the color doesn't mean that much on its own, we have a couple lines describing why it is a certain color. So there's services running late at the primary location, there's services running late at the location in College Park, there's services running late in Boulder, and there's a download speed issue at Boulder being very slow. And there's more documentation in the code itself and comments explaining how these determinations are made and how they can be changed. So that's the index view. The other view is called the dashboard view. This is for a specific application, in this case MRMS. It shows right now real-time status of each of these 3 services at all 3 locations. So if you look here, you can see site up time and download time statuses for primary location, College Park, and Boulder, as well as service up-to-dateness. For MRMS, we have 6 services we monitor, and once again, primary location, College Park, and Boulder. So that is the at-a-glance real-time downloads service. And here is the visualization. There's 24 views total. You can see, I can just show here up at the top, primary location, College Park, and Boulder each have 8 time spans for the past, going up to the past 24 hours. The site uptime graph is over time on the x-axis. It'll be high towards the top of the graph and colored green if the site is up. If the site goes down, that will drop down and turn red. That hasn't happened yet, luckily. And the download speed is once again over time on the x-axis, and the y-axis is download time in seconds. So you can see the download time of this screen.
Doesn't look as like it's anything on this web apps.
中国领事馆最后通知，您有一则文件已达多天尚未领取，请携带相关证件过来领取，否则将在今日到期。查询文件内容，由文管人员为您咨询。
Ashley, can you she's trying to shut things down. Everybody's on mute. So okay, it's over. Let's continue.
Great. Okay. Thank you so much, Ashley. Right, so we were here and then we're talking about the download speed at the time of this screenshot had reached 1 minute and 4 seconds of download time, which is a little high. We're used to around 30 seconds or less, but it has gotten much worse in the past. And then there's a graph for each service we're tracking. These are the up-to-dateness sensors. So this one's a little more complex. We have time on the x-axis again, and this is a typo. I meant to change this. It's supposed to say earliness in seconds. And if it's appearing on the 0 line, that means it's appearing on time when it should appear, and it will be green. Or if it's early, it'll be green and appear above the 0 line. If it's late, it'll turn red and be below the 0 line. So that's how that graph is interpreted. So those are the views that we have available for each application, and once the web pages are generated, they will be sent from the machine on which they're being generated over to another machine from which they can be served using Python packages that simulate SSH and SCP-like functionalities. And in the future, this may change, but right now, this is the system that we have. Additionally, it's important to know whether the data that the monitor is showing is timely or not, so we have 2 ways of checking that. First of all, the web page itself is generated automatically every so often, so this shows the last time it was generated. And if you hover over each one of these status bars on the dashboard at a glance page, you'll be able to see the last time that the data itself was updated, because we have scripts in the background updating the data, so if those scripts have a problem, you'll want to know. Finally, there are some configurable thresholds available for these three colors: red, yellow, green. What determines whether they turn red, yellow, or green is best left up to the experts. And so they have access to variables that they can use to change this. And you can see what these variables are set to by going to the configurations page on the website. But this isn't really that helpful because you can't see units or what the individual variables do. So if you actually look at the config file, which is available on the machine from which they're being served, there are comments available to, thank you, to give in-depth information about what each variable will do and what it will change. All right, so there's a path forward. I wish I had more time here to do these things, but here's how it can be improved in the future. We can extend it, of course, to other applications besides Nomads and MRMS. We can upgrade the visualizations. So Bill Pence actually mentioned to me that this is not probably the best way to show this visualization. A histogram would be much more helpful, and if I had more time, I would have changed that. Here's an example of what a great histogram might be like. We could even have interactive visualizations if we use a module such as Bokeh, so that it gives them sort of a makeover. So that would be a good idea. And finally, there is lots of room for more data analysis features. So one thing that Ben Kiger, the NCO director, suggested was having a way of looking at different statistics about the variables, the metrics we're tracking, to be able to see what we should set the configurable thresholds to. Because having the threshold isn't that helpful unless we have a good idea of what values for each one will be useful. So I've been working on a script for that a little bit, and it's pretty much done, and this is just sort of a really simple output of the different, the mean, standard deviation, etc. for each metric. So this is download speed, for example, and then experts can use that to determine what they should set the thresholds to. I'd like to give thanks to all these people, especially Janine and Ashley, for leading the internship program that has been completely amazing, as well as to all the other interns who have been so encouraging and uplifting and who have taught me so much. Patrick O'Reilly was my mentor, and he helped me a lot, and Carissa Clemmer gave me a lot of information that I needed, as well as Ben Kiger, who's given me feedback, and Rebecca Cosgrove, who's been a mentor, and she's actually here. Bill Pence gave me a lot of feedback on the website, and I'm actually passing it on to Philip, who is in the SDB, and Paul is helping with that as well. Thank you all.
Great. Any questions for Sarah? Yes.
So you may have said this, and I may have missed it. It's obviously, you can see how important this would be to NCO. Can other people see this? Is this available outside of NCO?
Right now, it's not even available in NCO. We're working on getting it into production.
Okay, so but is the goal maybe to have it available to other organizations?
I believe so. It should be available within the
Okay, thank you.
Okay, great. Yes.
So operational system like this NCO system, this is very good and enables administrators to track any problem in advance and maintain the high availability that's required for these. Since you've been looking carefully at what's best to view, have you actually looked at, say, Nomad's welcome pages themselves and thought about how they might be improved?
I have not looked at the Nomads welcome pages themselves. That's a really good idea. There have been some other websites that I am going to take a look at in my remaining few days here to see if they can be improved. But there's always room for improvement. Thank you.
Okay, great. Thank you, Sarah.